All right, welcome back to the WeatherXM updates. This time we've got Stavros, who is a meteorologist and the head of the Weather R&D team. Stavros, welcome to the WeatherXM updates.
Hello, Nick.
I'm psyched to see it. You and I have been talking on Twitter for years about various weather stations, but I thought we'd spend some time talking about this just released QoD, or quality of data. So, can you give me a broad overview of the quality of data mechanism? How does it work? What does it look for?
Okay, this is a short question that requires a massive answer, right? First of all, we should clarify that the quality of mechanism, or as we call it, QoD, as a shortcut, is a broad mechanism that will consist of several different parts, looking at different aspects of the quality of the data that we measure. And we actually used multiple Weather Meteorological Organization guidelines and papers, studies, scientific studies to derive all this stuff. The QoD short-term roadmap is actually paved by 4 different phases. The first step, let's say, makes a series of basic control checks about availability and validity of data, like the detection of spikes, constant data, and the reception of data at certain periods of time. There's a second step, which is the integration of what we call indoor station detection, or ISD. This algorithm utilizes the observed solar irradiance and makes some comparisons with the theoretical solar irradiance that we calculate for a certain region and day. We have been testing this algorithm for some time, and results are very promising against detecting all the weather stations that send data from inside the house, for example. The third step, which we call solar obstacle detector, or SOD, is an exotic, more complex algorithm that, again, looks into solar irradiance of several months and tries to identify cloudless days and then detect systematic shades in the diurnal solar irradiance curve. With this method, we will try to detect tall obstacles around the weather station that significantly affect our measurements. This mechanism, together with the previous one, the second one that we mentioned, are novel and unique contributions to the meteorological industry, and they could become a patent that we have created here in WeatherXM, but we have published them as an open source with papers and all this stuff. And the final step of this mini roadmap, let's say, aims to compare between reference, or let's say reliable weather stations of ours, or third-party stations, against stations of our network that we do not trust yet. What to say that
Got it.
all
Okay,
these...
so let's just take a hang on a
Okay.
hang on a second. Let's do a quick pause there. So
Okay.
we'll just review those 4 things, because that sounds like the basics of QoD, where we're just making sure, like, hey, the station's not inside. It's not, it's not got anything crazy going on. We're checking against other stations. This is just what I would call or think of as like a threshold set of steps. Am I understanding that right?
Yes, I would say that you're right. But for example, the SOD, the solar obstacle detector, is something that it's more complex. It's not that that basic. It's actually more than a threshold, because we try to find similarities between curves in solar radiance day by day, and then decide if there are systematic obstacles, systematic shades on the sensor. So this is a kind of more complex, let's say. And of course, when we will have uh, this mechanism that will compare weather stations together, then this seems to be much more complicated. I mean, we're still planning this final step, so there's more to come, of course. Yeah.
Yeah.
Mhm.
Super exciting. And now, I guess the next part, there's some photos coming. Tell me about those.
Yeah, so it's really worth to say that all these small mechanisms that we mentioned before will be facilitated by a mechanism which will collect photos of the deployments of the weather stations and I can definitely see deployment photos to play an important role in the solar obstacle detector, for example, and the final step, which is the comparative method, because one of the ideas is that if you get a warning that you have significant obstacles around, then just send us a few pictures. If you have different opinion about that, just send us a few pictures in order to cross-check the results. This will be really valuable for us and also for the user.
Got it. Okay. Cool. Super cool.
Mm-hmm.
So let's see. So once the QoD kind of finishes up, what happens? What happens next?
Okay, so I would like also to say that once QoD concludes a score per station per day, it is then passed over the reward mechanism that runs another series of checks and algorithms like proof of location, cell location, the hexagon, hardware class. But now let's focus on the QoD for now. I mean, this is just QoD is just a part of a general reward mechanism, right? Mm-hmm.
Yep.
Mm-hmm.
Cool. And we had one thing happen just this morning. We're recording this on November 23rd, Thanksgiving here in the US. I'm very thankful for WeatherXM. I think this is such a cool project. And we had a little bit of a blow up on the Discord, the QoD, whatever went down or something happened. So I think we can expect in the next couple weeks a little bit of turbulence. But let's kind of walk me through what the QoD is that people have already experienced and that what you guys are looking for. What a couple main points that you guys are looking for in the data.
Right. Yeah. So for now, for the current version of the QoD, we have four main points that we look into our data. Firstly, we look into values that are out of the boundaries that the sensor manufacturer has initially set. So as an example, the temperature cannot be 100 degrees Celsius. This is out of this world, let's say. Then we check for constant values. Then we check for constant values for a certain period of time. As an example, wind cannot remain constantly at 0 meters per second for 9 hours under a dry or semi-dry environment. And this is something that actually arose by our data analysis, as WMO suggested a much tougher threshold. So we tried to adjust some of the thresholds that we apply on our hardware. And what is really important to know, our users know, is that we look into the availability of the data. Maybe here there's a small misunderstanding. So we expect, so this first version of QoD actually looks into the frequency of the data that we receive the data. So we expect certain data packages within certain periods of time in order to calculate valid averages in minute and hourly level. This means that except for the deployment, they also need to ensure that the weather station communicates well with the Wi-Fi or helium or cellular network. And in the case of an M5 or cellular, they also need to ensure that the gateway communicates with the outdoor sensor. And finally, we look into suspicious spikes and dips in the data. There are certain thresholds set by the WMO that indicate unrealistic variations on the meteorological variables, which may be due to faulty sensors or bad deployments. So, as an example, if we detect a spike of more than 3 degrees Celsius within a minute, then this is quite suspicious and unrealistic in a meteorological way. So we annotate this spike, this variation, as suspicious. And this is actually
okay. So there's a
what
couple
is
steps.
the
It's kind of cool.
Mm-hmm.
Super cool.
Mm-hmm.
Yeah, neat to see. And obviously this is just the first iteration of this, but it kind of starts off and we got, all right, are the values out of bounds? Is this thing off this world? Is it static? Is it not doing something under certain conditions? Pretty interesting to think that the WMO, the World Meteorological Organization, has said basically if it's dry out, if it's super dry outside, there's going to be wind. And if there's not, then there's something wrong. And then there's the availability of data. So like, are you actually getting the data once we've done these basic thresholds? And then at the end, are there suspicious spikes? So is this thing, and these are not going to be caused by the passing of clouds over the sun. This is something that is way outside natural phenomena. Okay. I think I'm getting all that. How, I know we had said that the stations come from a manufacturer. Right now, the manufacturer is WeatherXM. In the future, we'll have more. How accurate are these stations? I've got one up on my house. I got one out in the mountains. How accurate are they?
Right. So this is a really nice question. Each of our weather stations comes with some specifications, and as all of the weather stations should do, for each of the included sensors. So our sensors have an accuracy of 0.2 degrees Celsius in temperature, 5% in humidity, 10% in precipitation, less than 10% in wind speed, and less than 15% in illuminance, and around 1 millibar in pressure. These specifications, I would say, make our low-cost weather stations a hardware for representing the weather conditions over an area in pretty good accuracy. So yeah, I think that I'm really
Okay.
happy with this kind of hardware. I mean, it's a kind of value for money, let's say.
Yeah, yeah. Now, how does it stack up against other weather stations?
Mhm. I would say that such specifications that I already mentioned are quite comparable to those of more expensive weather stations with a cost of a few thousand euros, let's say. Of course, a station that costs 10,000 euros provides better accuracy and precision than our low cost weather stations. But the point is that our weather stations are a value for money solution on the way to creating an extensive weather network and representing the global weather. Also, worth noting that no matter how expensive a station is, if it's not maintained properly, it will collect unrealistic measurements. What we often see with governmental networks, for example, is a huge percentage of stations being offline or having faulty sensors, and typically takes months or even years to repair due to bureaucracy. So uh, again, I would say that yeah.
So it's not value. I mean, oh, that's really interesting. You could have a $10,000 weather station, but
Mhm.
if the government, and I don't know what the government's like in Greece, but it's certainly not fast moving here in the US. If they don't get to it and fix it, within a day or an hour, which is super unlikely here, it doesn't matter how expensive it is. It's not going to collect the right data. Okay,
Yep.
cool,
So this
super
is
cool.
actually the power that our community has to restore or to make the weather station work properly very very quickly, right?
Yeah, yeah, yeah. No, it's a super cool thing. I think this is one of the leverage points for deep ends is that you got a bunch of individuals who are motivated to keep these things working.
Mhm.
I guess the fundamental question here is how do I know that my data quality is good?
hmm Actually, this is the reason that we are developing the quality of data mechanism. Actually, this is the first time that the global network is evaluated continuously and so rigorously as we do. We are trying to create a health monitoring system, let's say, for our network in order to know which stations are problematic in terms of deployment, sensor status, etc., and which are functioning uh, as as expected. Our UX team, I would say, has a challenging job on communicating such information to the users. And in the future, we aim to give tools to our users for tracking hour by hour the quality of data of their weather stations through our apps and get recommended actions to solve any issues. So we are not there yet, but eventually, this is our goal.
Right. Right. And I mean, I think we're all seeing the new app come out and it's saying like, hey, here's what's wrong, whether it's like fix your wind speed or, a couple frustrating instances like, oh, it's unknown, something is wrong. But I think those are just steps on the way. And it's really cool to think about. I mean, I've got more expensive weather stations that are not WeatherXM stations that don't do that. Right. If they go down, you have no idea why they go down. It's just maybe it's not working or maybe it's reporting a false value. And there's nothing in there that I can see on these stations that tells you kind of what's wrong or what to look for to fix. So that's a pretty
Mhm.
significant advantage that WeatherXM
Of
has.
course,
Now,
yeah.
the other day, I think you and I might have been talking about this. It might have been someone else. My rain cup, it's embarrassing, but it filled with bird shit, and I had to take it down and clean it out, and then put some little spikes on it, which we can talk about in a second, and put it back up. But if one data point like that, like the rain cup collector, is bad, does that kill my score totally?
No, we aim not to penalize our users in such a way. What we really desire is to be able to produce accurate minutes, hourly, and daily averages of all the parameters that we measure. So, if a single time slot has no data within an hour, this will not work negatively to the scoring process. However, I would like to say if something blocks the rain gauge or the wind gauge permanently, this will trigger a series of consecutive faulty measurements, right? So it will not block. It will not be blocked just for one moment. For 1 second, for 1 minute, or even for 1 hour. So this will be penalized, and the reason is to warn the user that something is going wrong.
Got it. Okay, so I want to make sure I understand this because we're going to get a ton of questions on this.
Mhm.
If my rain gauge is blocked for an hour, does that mean that my station, or let's say it's blocked for 6 hours, I don't notice it, or some eagle comes along, does that mean for 6 hours, even if the wind vane is working and the temperature and the pressure and the humidity, even if all those are working, does that mean that I lose rewards just because one parameter is off, or am I not understanding that fully?
We handle each parameter separated, so you will not be rewarded for the precipitation, but all of the others. I mean, every single datum is worth, and so we evaluate we give the value to the user. I mean, for every single parameter. So actually, if the rain gauge is blocked, then I would say that if there is no rain for that moment, you will not be penalized. But if there is rain and you lose it, then you will be penalized. But this is in a future version of QoD, of course, not in this current version. Okay, should highlight that.
Okay, I'll do one more question about the rain cup that is not in our notes. I put up some bird spikes because I didn't want the birds pooping in my rain cup.
Mhm.
And then I saw some discussion on Discord that the rain spikes might be good, might be bad. Mine are pretty small. Is there anything that you've got to say about bird spikes on these rain cups to help people make good deployments?
So it depends on how big, how tall these spikes are, because sometimes these spikes shade, for example, the light sensor, and this may trigger losing other rewards because the luminance will not be the what's expected. So yeah, it needs
Got it.
some
Okay.
you know. Mhm.
Okay, cool. I kept mine I kept mine pretty thin, but that's super useful to know. Is there a most important parameter? Is there one that you want above all other parameters?
Yeah, this is a quite tricky question, and when I joined the WeatherXM, it was one of the first questions actually. But I can answer this, I can answer this question in that way. Different parameters are important for different applications. So we now measure the typical 7 basic meteorological parameters because all are important, of course. For example, feeding a traditional numerical prediction weather model, we need temperature, pressure, humidity, wind speed, and direction. However, precipitation is important for hydrological applications. So let's say, for example, that a shower over a mountain may affect the energy production in a dam on a lower ground area, or create a flood in a city, or create traffic, logistic issues, etc. So we do not use precipitation to feed a weather prediction model, but we need precipitation measurements for another reason. While another example is that solar irradiance can be used for optimizing energy management in solar farms. Hence, whatever we measure is important for different use cases, and for different customers. So the reason that we measure these parameters, I mean, we measure these parameters because there is a reason. So all are important.
Right. I guess it's like asking, like, hey, which of your fingers is most important? Like, well, your thumbs are pretty important, but I don't want to lose any of them.
Exactly.
Okay,
Yeah,
that
exactly.
makes sense. And I guess depending on what you're doing.
Mhm.
Yeah. Um, let's see. Now, one of the questions I saw in the community is that if our quality of data hasn't been good in the past, why haven't you guys flagged it over the past 2 years?
Mhm. We needed to conduct experiments and tests in order to develop a series of mechanisms. So this is a process that takes time, of course. As this is the first time that ever that such a mechanism will be applied continuously, of course, there are lots of challenges and issues that we should tackle. We are now in the first implementation of QoD, which I described previously in the previous questions, and we should know that a QoD future version will be applied retrospectively to all the data that have been produced till the beginning of the operation of this network. So yeah, we
I mean,
haven't
this is an
done.
important point, Stavros, is that
Mhm.
no one's done this before, right? Like across a network in real time. I think that, this point gets lost a lot where people are like, oh, why isn't this thing ready? What's going on here? It's like, this hasn't been done. We're building something totally new, and it's it's energy and information intensive, and B is it's super complex. So I think this is an important point, not only for the reason like, okay, why didn't you guys tell me my data was bad before? It's like there was no way of knowing. And then we built up this mechanism using that data. And now there is a way or a glimmer of light of like, hey, this is how it'll work.
Mhm.
Pretty impressive to see what you guys have done so far, and obviously super exciting for the future.
Oh, yeah.
Okay, the big question, let's see, will there be any kind of algorithm to compute earnings? Walk me through that.
So we aim to release the entire reward mechanism in QoD validation as open source software, so anyone will be able to run all the series of algorithms that compose the reward mechanism that I previously mentioned and calculate the final rewards for the data of a weather station. Just as a reminder, the reward mechanism includes additional algorithms that check the location of the station. So we need to have proof of location, for example, the quality of data, which is QoD, and even the model of the hardware, so the hardware class, let's say, in the future.
Got it. Got it. Okay, I got a couple more community questions and we'll wrap this thing up. I know
Mhm.
we're a little bit long, but this is a giant topic. I appreciate you making the time.
Yeah.
Um, all right. Sometimes there's here, I'm just reading a community question. Sometimes there's a significant difference between my station on a farm with big open space, no obstacles, good elevation. And then I check a station in the next hex over, which I think is in a more built up area. And the difference in data is certainly noticeable. What
I
do you
really
think
like
of that?
I really like this question. Is quite meteorological, I would say. So that's totally reasonable, and it should happen. That's the reason that we have included the land use parameter into our cell modeling as well. So we need weather stations at different land uses in order to represent different microclimates in a broader area. So an urban area has different temperatures at night, for example, especially during the night, compared to a neighboring rural area due to a phenomenon called urban heat island effect. And this is only one example among several that we can observe. And we actually we can actually have different measurements at different land uses. But what we should keep in mind is that it's not a good practice to compare two weather stations that are deployed over different land uses in order to find which one is reliable and which is not. So it's not a good practice, especially if there are different land uses. It's a different thing. It's a different microclimate.
Yeah, totally. That's I the weather is so cool. Like, and thinking about all this stuff, I get super
Mhm.
sidetracked. Well, let's stay on track
I
here.
can talk for hours.
Is there a will there be a scale system? Right? Will there be a scale system for data quality?
At the moment, it's all about time. So the more faulty data you have within a day, the larger the penalty will be. In the future versions of QoD, it's possible that there will be a kind of classification of the deployment. So one of the ideas is that a weather station will be marked with a certain score, which will characterize its deployment quality. So in the future, we may have a kind of scale system, but for now, we want to collect valid data at certain periods of time. This is what users need to keep in their minds.
Got it. Okay, and then last one, I think this thing went live, this new reward algorithm went live sometime this week, started yesterday. We started seeing some problems popping up right away. Walk me through kind of what it looks like in the next, I don't know, week or so, and the rollout of it.
Yeah, so the QoD version 1 algorithm is running in production now and is part of the beta phase. So please be patient as we fine-tuning the QoD now, the mechanism, the first version. All the weather station data are already evaluated for their quality, and rewards are calculated as a function of the quality. This is the point. However, the rollout of the reward mechanism, which is a different thing. So I'm trying to separate QoD from reward mechanism. It's a different thing. QoD is just content, is just a small part of the reward mechanism. So how the rollout of the reward mechanism 1.5, this is version 1.5, is a gradual process where all its components will get in motion one by one within the next few weeks.
Cool. Stavros, it's got to be super exciting to be the head meteorologist on a project like this. Tell me a little bit about, like, what are you thinking? What are you feeling as this thing kind of rolls out? Are you super excited? Are you super nervous? Where are you on this thing?
First of all, of course, a weather company should have a meteorologist, right? So yeah, I'm really excited. I mean, this is actually a dream project for me because covering the world with thousands of weather stations is really, really exciting, a really challenging process. The fact that you have the power to analyze data, weather data across the world, it's super cool. Yeah, and I'm really excited to be in this project, in this team. Is I'm really happy about that. And I
it's super
hope
cool.
that
I'm so stoked for you.
our users will be also happy. I'm really happy to share any meteorological thoughts, ideas, anything, knowledge with users. Yeah, that's great. It happens.
Love it. Love it. Well, I got my little weather station right there behind me. That thing's been awesome. I appreciate you and the work that you've been doing on the project. And thanks so much for taking the time today to walk us through that. I know it's a ton of information.
Yeah, thank you too.